For section 5.5 on complex numbers and roots, we are going to split this up over the next few days. So we're just going to do the very basic part today. So talking about when we solve something along the lines of x squared plus 1 equals 0, we would get x equals the positive or negative square root of negative 1. And I would have you write no solution because we cannot take the square root of negative 1. So therefore, there is not a solution because it's not a real number. Now, we're going to talk about imaginary numbers, and that is when we take the square root of negative numbers. So the imaginary unit is I or the square root of negative 1. So those are interchangeable. So that's very, very important right here. I is the same thing as negative square root of 1. All right, so this kind of gives us the definition of an imaginary number in words that we just talked about. And it's kind of blurry, but at the top here in the middle, the square root of negative 1 is I. So we talked about that one. Here is where I kind of show you how to break them down. The square root of negative 2, if I broke it into two problems, that negative sign is really a negative 1, and then we have 2 left over. Well, we can interchange that square root of negative 1 with I, so then we just have I square root of 2. The same thing here with negative 4. It simplifies down a little bit better. That negative sign is like the square root of negative 1, so that's broken off by itself, and then we have the square root of 4 left. We can take the square root of 4 and get 2, and then the square root of negative 1 would be I, so that simplifies down to 2I. So anytime we have a negative square root, we put them into two different problems and then simplify down. So the square root of negative 1 squared, well, the negative square root of negative 1 is an I, so I squared, and I times I, negative 1. So the top one here and the bottom one are the ones that are going to come up that you're going to have to remember and use. So I guess another way to explain that is a square root and a square, so that 2, that exponent, cancel each other out. So this is gone and this is gone. So we're left with that negative 1. That might be a little bit easier to understand as well. And then, of course, over on the left-hand side or the right-hand side, we have the algebra with the variables. So same thing as in the middle, but only using variables, can't simplify down as much. All right, so for example 1, we need to express each number in terms of I. So we have 3 times the square root of negative 16. So we're going to leave that 3 out there. That negative sign is like a negative 1, so square root of negative 1, and then we have the square root of 16. Well, the square root of 16 is 4, and the square root of negative 1 is I, and then we have that 3. So we can multiply the 3 and the 4 together to get 12, and then we have that I left. So 12I is the simplified version of 3 square roots of negative 16. And then over here for B, we have a negative sign out front, so we can't do anything with that. And then we have a negative sign underneath the radical, so that would be the square root of negative 1 times the square root of 75. So now we need to break that down. And we are going to use perfect squares, and the list of perfect square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Of course, they go farther than that, but that's the first 10 perfect squares. So those are the numbers you can take the square roots of and get whole numbers. So we want to find one of those that can go into 75. So 25 goes into 75 3 times. So I'm going to break the square root of 75 up into the square root of 25 times the square root of 3, because 25 times 3 is 75. The negative the square root of negative 1 is I. and then we have that negative sign out front. So we simplified that down a little bit, broke it down. The square root of 25 is 5. We have this negative I, so I'm going to put the negative sign in the front of 5, and I'm going to put I behind the 5. And then we have the square root of 3, which doesn't break down any farther. So negative 5I times the square root of 3. Another one here, we have a fraction out front, so we're not going to do anything with that just yet. Square root of negative 63 would be, the negative sign is a negative 1, and then we have the square root of 63. 63 is 9 times 7, and 9 is in my list of perfect squares. So 63 is 9 times 7, so we can break that up. The square root of negative 1 is an I, and then we have this negative 1/3 out front. Then the square root of 9 is 3, and we have to multiply that by negative 1/3. We also have to multiply that by I and by the square root of 7. So I'm going to worry about the fraction and 3, negative 1/3 times 3 right now. I'm going to make 3 into a fraction. On an angle, those cancel, and I have negative 1 over 1, which would be negative 1. So I have negative I, or negative 1I, and square root of 7 left. And our last one like this is the square root of negative 12. So again, that negative sign represents a negative 1. And then we have the square root of 12 left. 12 is 4 times 3. So we have the square root of 4 times the square root of 3. And the square root of negative 1 is I. And then we can take the square root of 4, which is 2. We're going to write the I behind it. And then we have the square root of 3 left. So the simplified version is 2I square roots of 3. Then the other thing we're going to talk about is how to solve equations using these. So we want to know what x is. So our goal is to isolate x squared by itself, which in part A here is already done for us. So to cancel out the squared, we'd have to take the square root. So we would have x equals the square root of negative 81. So we're going to break that negative 81 down. We have the negative sign, which represents a negative 1, and we have 81. Well, the square root of 81 is 9, and the square root of negative 1 is I, so we have 9I. Don't put the I in front. That's just not right. All right. And then B, we have to isolate the x squared here. That's not done already. So we're going to subtract 75 from both sides. And we're going to have 3x squared equals negative 75. And then we have to divide by 3. So x squared equals negative 25. And then we need to cancel out that squared, so we're going to take square root of both sides. So we have x equals the negative square root of negative 25. The negative sign is like a negative 1, so square root of negative 1. And then we have the square root of 25. Square root of 25 is 5, and the square root of negative 1 is I. So our answer is 5I for that one. Again, we have to isolate the x squared. So we're going to minus 48 from both sides. So we have x squared equals negative 48. Square root to cancel that squared. So x equals square root negative 48. And then we're going to break this up. The negative sign is like the negative 1. And then 48, we're going to find the largest number that 48 goes into, that actually goes into 48 that's in our list of perfect squares. So the largest number that I found in that list would be 16, because 16 times 3 is 48. So we have 16 and we have 3. So the square root of 16 is 4. The square root of -1 is I, and then we have square root of 3 left over. And then for our last example, we are going to isolate x squared again. So we're going to subtract 25. So we have 9x squared equals -25. And then we're going to divide by 9. So we have x squared on this side. And as you notice, we cannot do 25 divided by 9 to get a nice number. So I'm going to leave it with -25 over 9 right now. And then I'm going to take the square root. So x equals, that negative sign is like that -1. And then I have the square root of 25 over 9. Now, luckily, 25 and 9 are both perfect squares. So the square root of 25 is 5, and the square root of 9 is 3. And then the square root of -1 is an I. So we have 5/3 I. The one thing I missed on all of these, that when at the very end, when we took the square root and we actually got a number, remember there's 2 answers to a square root, and you need to write positive or negative out front of these. So this would be positive or -4, because the square root of 16 is positive or -4. So I missed writing those at the very end. All right. So that is our section for today on complex numbers or roots. I think if you have a question, email me. I will get back to you as soon as possible.